Okay, let's keep going with the quadratic formula. This is part 2. All right, we have another equation. We have a little more going on here. We've got fractions for one thing, and we really don't want to put the fractions into the quadratic formula. But the other thing is that this is not in standard form because the 8/7 is over on the right-hand side. We need to move that over before we do anything. So let's go ahead and do that because we want to be in standard form. Now, the variable doesn't matter. Oops, 8/7 equals 0. Okay, so I slid that negative 8/7 in over on the left-hand side. So I subtracted 8/7 times both sides. And then let's go ahead and multiply everything by 7, both sides. And so when we do that, we get 3y squared plus 5y minus 8 is equal to 0. All right, so now we can grab our a, b, and c. A is equal to 3, b is equal to 5, and c is equal to negative 8. And let's get to work with our quadratic formula. So the first thing we're going to do is, of course, make a giant fraction. We want negative b. Well, b is positive, so we're just going to have negative 5. Then we're going to have our plus or minus sign. Then we're going to have a giant radical. So we want b squared. Now again, I always use the parentheses, so this is a 5. Sorry, that doesn't really look like a 5. 5 squared. And I always use the parentheses because then I don't have to worry about whether it's positive or negative. It's always taken care of. Then we have the subtraction sign under 4. That's part of the formula. It's always going to look like that. And then we're going to multiply times a, which is 3. We're going to multiply times c, which is negative 8. And then finally on the bottom, we have 2 times a. Well, a is 3 this time. This is the first time. It's always been 1 in the past. Okay, so what that leaves us with is we have a negative 5 out front. We have plus or minus and the radical. Let's look at that in just a minute. And then we're going to have a 6 on the bottom. Okay, so let's come over here and take a look at what's under the radical. Well, 5 times 5 is going to give me 25. And then I have, what do I have there? Negative 4 times 3 times negative 8. So that gives me 96. And that gives me 21. 21 is a perfect square. Okay, if you put the square root of 21 in your calculator, you will see that you get 11. So we actually could have factored this because we had a perfect square in the quadratic formula. That's our telltale. And so we'll go back and look at that in just a minute. But for right now, we cannot leave it in this form. If you type it into my math lab looking like this, it's going to say that although you have the correct answer, it is not in the correct format. And so what we're going to have to do is take care of both of these. We're going to take negative 5 minus 11, over 6. And then we're going to have negative 5, I don't want to do that, negative 5 plus 11 over 6. So let's see, negative 16 over 6 is equal to negative 8 over 3. So that is one of our answers. And then over here, we get 6 over 6, which is equal to 1. So those are our two solutions, negative 8 over 3 and 1. So we could have, way up here, we could have factored this in the first place. We would have, let's see, 3y and y. And then over here, we would have plus 8 and minus 1. Let me double check that. So 3y squared, 5y minus 8. Yeah. And so we would have found the same answer. But you don't have to factor. If you don't want to factor, you can throw this into the Casio and let the Casio do the quadratic formula for you. Okay, let's try another. All right, so once again, we have a quadratic formula that is not in standard form. So let's go ahead and slide that 7 over to the left, put this in standard form. There's no way to factor this one. We cannot find factors of 7 that would sum to 5. There's no way. So let's go ahead and grab our A, B, and C. So do not grab A, B, and C until you're in standard form, because you would grab the wrong C. You would say that C was equal to 7, which is not true. It's equal to -7. All right, let's get to work. All right, so the first term is -5, right, because negative b. Then we're going to put b squared under the radical. -4 is always there. And then we put a in, which is 1, and we put c in, which is -7. And then on the bottom, we always have a 2, but then we put a in that we multiply times the 2. All right, so let's take care of under the radical here. We get 25 plus, let's see, -4 times -7 is 28. And so that is going to give us 53, I think. Let me double check. Yeah, 53. Now, 53 does not have any factors that are going to help us out here. So actually, I think it may be a prime number even. So let's go ahead and go back over here and see what we have. So we have -5 plus or minus the square root of 53 divided by 2. And that's actually our answer. So if MyMathLab will let you put the plus or minus in, you are done. If it doesn't, then you're going to have to go ahead and separate these two, because we really do have two answers here. We have two solutions. They just look crazy, but they're really just decimals. And so we may have to separate these two fractions if MyMathLab will not take the plus or minus. And that's our answer. Those are our two solutions. Remember, if your largest exponent is a 2, then you're going to have two solutions. If your largest exponent is a 3, you're going to have 3 solutions. All right, so again, this problem is not in standard form. Now, it's really easier to have A be positive. Of course, if you're using your Casio, it doesn't matter. But so let's go ahead and move the 10x over and move the 2 over. All right, so now I have 9x squared minus 10x minus 2 is equal to 0. So now I'm in standard form. I know my A, B, and C, and I can get to work. Oops, -2. Okay, so we have the negative of -10 plus or minus the square root of -10 squared. Now this is a big mistake if you forget to do the parentheses, because you're going to end up with -100 instead of +100 when you square -10. So you have to have those parentheses. Whoops, I did not mean to do that. Let me fix that. It's supposed to be minus. -4 times 9 times -2. Oof, this is going to get big. And then on the bottom, we have 2 times a, which is 9. All right, let's come over here and take care of under the radical. So I have 100 plus, looks like 72, but let me double check. Yeah. So let's break out 172. All right, so we were able to pull out a pair of 2's, right here, but this 43 does not break down any further, and so I am done there. So let's go ahead. The negative of negative 10 is going to give me positive 10, plus or minus the square root of 172 all over 18. And then when I simplify my radical, I get 2 times the square root of 43 all over 18. Okay, so this is the first time that we've had something crazy like this that we actually can reduce. So remember, we cannot touch what's under the radical once we've simplified. So that square root of 43 is done. Even if we could divide it by 18, we're not going to because we can't touch what's inside the radical. Okay, but now what we're going to do is we're going to look at these 3 numbers, and if we can reduce them by something that's in common to all of them, then we will do that. If we cannot, it has to be common to all 3 of them. All right, so of course, we could divide all of them by 2, right? If we do that, we get 5 plus or minus the square root of 43 all divided by 9. Craziness, huh? And that's it. Those are our 2 solutions. We could separate them out if we have to, or hopefully my math lab is going to take that plus or minus. So the important one on this one is that you get it back into standard form before you try grabbing A, B, and C. And then when you get to the end, you have to look at all 3 of these numbers to see if you can reduce further. If one of those numbers had been odd, we would not have reduced further. All right, so once again, we have not in standard form, and we also have fractions. So let's go ahead, put it in standard form first. So I'm going to move that 8/3 over to the left. And then we have a common denominator of 3. So I am going to multiply every single term by 3. Don't forget to multiply in the middle here. So 3x squared over 3 would just give me x squared. And then 3 times x, I'd get plus 3x. And then 3 times 8 over 3 would get me the negative 8. All right. I think I'm good. And then, of course, 0 times 3 gives me 0. Okay. So now we're just going to substitute our A, B, and C. In front is negative b, so that would be negative 3. Inside the radical, we're going to have b squared, so 3 squared, minus 4 times a, which is 1, times c, which is negative 8. And then on the bottom, we have 2, and then times a, which is 1. All right, so let's clean up what's underneath the radical here. We have 9 plus 32. And so that gives me 41. There are no perfect squares inside 41, and so we're not going to worry about simplifying. And we are done. That is all we have to do. Because we couldn't simplify, we don't have anything in common that we can reduce. And so that is our answer. Those are our 2 solutions. Again, we could separate them out if my math lab makes us. We're going to separate them out into 2 separate fractions. Whoops. But hopefully all of these, my math lab is going to let you put the plus or minus in there.